For our objective for today, I can graph rational functions. Let's read it together. 1, 2, 3. I can graph rational functions. So we already covered rational expressions. We covered rational equations. Today we're going to start graphing rational functions. Okay? All right, so here we go. So I can graph rational functions. What are rational functions? We already seen this before. I gave you this for the equations. So rational functions are equations that contain one or more rational expressions. Remember these? Examples, non-examples. And we said the most important thing to remember is that they are equations that contain at least one rational expression. Remember that? That's where we don't need this. But we do need to write steps. Write these steps down, please. Steps. Identify the vertical and horizontal asymptotes. Identify the vertical and horizontal asymptotes. Identify the vertical and horizontal asymptotes. Step 2, build an input-output table. And step 3, graph the function. Okay, very good question. So for asymptotes, at the end, open up parentheses. The easiest way to remember asymptotes, they are invisible lines in a graph. Invisible lines in a graph. Kind of like dotted lines. Yeah, and I'll show you that right now as soon as you copy this. And if you notice by now, like a lot of the stuff that we've been doing, the steps, a lot of the stuff we already did throughout the year, but now we're doing a bunch of those things within each step, right? So it's not like we're really learning like a lot of things new. It's just that we have a lot of things within the step. Today we are, though, going to learn what asymptotes are, okay, and how to graph these. We already know how to graph functions, right? Build an input-output table. Remember those? You guys love building input-output tables and substituting values into the equation and getting your y value and plotting the point. Remember that? All right. So identify the vertical and horizontal asymptotes. So check this out. On the side, let's sketch a coordinate plane. Let me get that ready. You can do it right here on your notes. It's just so that you clarify what asymptotes are. So here's my coordinate plane. All right. And the easiest way to describe an asymptote, I said, invisible lines. Invisible lines. And I'm going to use a dotted line so that you can imagine them invisible. Okay, so here we go. I'm going to first sketch a graph. So to put it easy, here it goes. Here's a graph right here. Here's another one. Now, let's think about it like this. Who remembers watching, I'm pretty sure you probably watched this sometime back with your parents. This movie's called Independence Day with Will Smith. Oh, yeah. You guys seen that one? Yeah. Where they're about to, they go up on their F-14s, they're about to bomb that spaceship, right? Oh, yeah. But there's a force field in front of it, and all of a sudden they have to kick in the extra burners, and everybody look at this graph. So imagine the jets coming this way, they're about to bomb, but they sense there's an invisible field, and they go up like this, right? In order not to hit it, because there's an invisible field. Therefore, those invisible fields in our graph, I'm going to use a dotted line so you can see them. There it is. And also another one over here. These are known as asymptotes. Now you're saying, that sounds kind of weird. Yes, it does. However, I've already got you guys already doing these from equations. The only thing we call them something else. Check this out. This is what we call them. We call them excluded values. Who remembers that? Yeah, right? Excluded values, from now on, imagine them, they're known as asymptotes, and when we graph them, they should be our invisible lines in our graph. Okay? Yeah, asymptotes. Okay? So, does everybody understand this? So pretty much, imagine, like I said, imagine here's the path of the jet. Here's the jet coming this way, but then they sense there's a force field and they have to pull up, and therefore that force field doesn't let them get close. Is that correct? So those are our asymptotes. Now, today we're going to be graphing rational functions, and the last two steps are pretty much the simplest steps ever. It's just a lot of computation because we have to substitute, get a value for each of our y values, and so on and so forth. Okay? So before we move on, I want us to practice finding our excluded values, also known as what? Asymptotes. We're going to be finding our excluded values, also known as what? Asymptotes. Okay, so copy this down. Example number 1. 1A and 1B. So it says, identify an excluded value for each rational function. So here we go. So let's do this one together since we already know, but just to refresh your memory, I remember when we came to expressions, I wrote EV over here on this side. Remember that? And I said in order to find the excluded value, we write the denominator equal to 0 and solve. So what is my denominator here? X, and we will write that equal to what? 0. So my excluded value is 0. This is known as my asymptote. Are we there? So check this out. So if that's true for this one, let's find the excluded value here. Excluded value for the second one, we write our denominator equal to 0, x minus 2 equal to 0, and we solve. What do we do to solve? Inverse operation, so we add 2, x equals 2. And this is my asymptote. And when we did graphing of linear equations, remember when there was x equal to something, it was a vertical line, a line going through that x value. That's why this is known as a vertical asymptote, both of these. Now check this out. Now let me show you what it would look like on the graph. If I was to ask you to graph something like this, the asymptote will be crossing at what? On this one, at 2. So check this out. So let's say this was the graph, and my asymptote will be crossing at 2. Does everybody see that? This is my asymptote. You're saying, wait a minute, Mr. Q, so how do we get this one? I'm going to show you that in a little bit. Right now, we're just working on this one. Are we there? Okay, let's do another one. Copy this down, please. Example 2. Copy those down. Do those by yourself. Find me the excluded values or my asymptotes. Y equals 10 over x, and y equals 4 over x minus 1. All right, check with your neighbor for the excluded value, see if they have something similar to yours. Check with your neighbor.
I got 0 and 1. Wait, I thought we had the graph. Graph.
Right. So right now we're just finding we're finding the x asymptote. I'm going to show you how to find the other one, and then from there we're going to graph. Okay. I'm just going step by step so that you can follow me all the way. Yes.
What is the other one? The y?
The y asymptote. Here we go. So this one was x minus 1 equals 0. So add 1, x equals 1. Hands if you got 0 and 1. Okay? So far so good, right? Yeah. So let's not do this next one since we already know how to find our excluded values. And I want you to copy on the left side of your paper, if it fits on the Q side, I'm going to give you the form of the rational function. You know how throughout the year I've been giving you different forms of equations? Y equals mx plus b, which is a slope-intercept form. I gave you guys a standard form, point slope form. For quadratics, I gave you standard form. I gave you guys what other? The quadratic formula and so on and so forth. There's an actual form for rational functions. Copy this down, please. Y equals A over X minus B plus C. On the left side. If it fits on the Q side, there. If not, as far left as you can on the note side. Okay? So Y equals A over X minus B plus C. And this is called the rational function form. Rational function form. And if you notice, it's got a couple of pieces that are highlighted. Do you guys see that? So check this out. This piece right here, bless you, that's in green. That one is my vertical asymptote, which is my X asymptote. So if that's my vertical asymptote, which is the X, what do you think this would be? The Y asymptote. So this is known as the horizontal asymptote. And this is my Y asymptote. That's how we find that other one that we hadn't computed yet. And what is this good for? This form is the fact that as soon as you see an equation and you know the pieces of it, you will be able to identify the asymptotes without actually doing any computation. Okay? So check this out. So with that said, did everybody copy that?
Yeah.
All right. So with that said, I'm going to go ahead and move on. I'm going to erase this, and I'm going to ask you to copy on the right side of it. Example 1. Copy this down, please. Example 1, copy this equation. Y equals 1 over X minus 3 plus 2. And the reason I want it side by side so that you can see a couple things using that form. Okay? Y equals 1 over X minus 3 plus 2. All right? Okay, pens down, please. Let me show you a couple things to make sure you see what I see. Pens down. Writing utensils down. Here it goes. So, this is the form, and you're saying, wait a minute, this looks almost exactly like this. Because it has a Y, yes. It has an equal sign, yes. It has a value on the numerator, yes. Has an X on the denominator and a minus, yes. A plus right here. So what are the only two things that you see might be a little bit different? The value of B, the value of C, and the value of A, right? But what do we know about B? The B is the vertical asymptote and C is the horizontal. So check this out. So my vertical asymptote here would be 3. My vertical asymptote, my horizontal asymptote will be 2. Why? Because check this out. Why didn't I say minus 3? Because the minus is part of the form, isn't it? Yeah. And they're only highlighting the value of B. Copy that, please. Okay, copy this next one down. Let's do this one together. Example 2, right underneath that. That was it? We're just identify asymptotes. And then I'll show you the graph. But the graph is easy. You already know how to do graphing, right? I just want to make sure that we identify asymptotes right now. Here we go. Example 2. Copy this down. Y equals 1 over X minus 5 plus 23. Michael Jordan. Okay, here we go. Y equals 1 over X minus 5 plus 23. See if you can, by looking at it, let's see. See if you can identify your X asymptote and your Y asymptote. Yeah, right now. Just by looking at it, right? So, let's see. Who got x equals 5 and y equals 23? Answer if you saw that. That is correct. Why? Because what is the value of B right here? 5. The value of C, 23. Are we there? Okay. Let's do another one. Here goes a curveball. Ready? All right, here it goes.
Just wait on it.
Yeah, just wait on it. Yeah, here it goes. Y equals 1 over x plus 7 minus 5. Y equals 1 over x plus 7 minus 5. Okay, so check this out. First of all, who notices that this is a plus instead of a minus? Are we there? Okay, so check this out. Who notices that this is a negative? Okay, so from now on, let me show you the vertical asymptote. X equals negative 7. Okay, how do we find the excluded value? X plus 7 equals 0 minus 7 minus 7. X equals negative 7. So, the only one that does not change, everybody look up, y equals negative 5 because it's a constant. These were positive 2, positive 23, and this is negative 5. You're saying, Mr. Q, but if on the form it's a plus, why do we write negative 5? Because this could be written like this. Everybody look up, please. This could be written as, does everybody see that? Yes.
How come on the other ones though, it's positive 2 and then positive 23, but how come it goes negative?
Well, that's what I'm saying. Because if they give you this as a negative, you can rewrite it, can't you? Here's my positive. So this will be a positive. This changes to negative 5. You see it? Here it goes again. In order to change this to a positive, this has to be a negative. That's why this is negative 5. Another way of looking at it, guys, from now on, when I ask you for the horizontal asymptote, all you have to do is give me the constant. What is my constant here? And here? And here? Negative 5. That's how you just identify. The only one that you need to worry about of doing the opposite is for the vertical one, when it's a positive number here. Are we there? Right. Let's do another one. Example 4. Copy this down. Example 4. Y equals 1 over x plus 23 minus 2. So, my x asymptote is negative 23, and my y asymptote is negative 2. That is correct. Are we there?
Yeah.
Okay. And that's it. The next parts are easy because all we have to do is build an input-output table, fill it with values, and graph by plotting our points. Now, let's do that. On your big graph paper, let me just get you guys started. Here we go. I'm going to copy the first equation, which is y equals 1 over x minus 3 plus 2. Here we go. Copy that down. The equation y equals 1 over x minus 3 plus 2. And this is why we need our asymptotes. Here we go. By looking at it, hold on, we're almost there. By looking at it, what is our x asymptote? 3. So you get your graph, and we're going to graph our x asymptote going through number 3. There it is. What is our y asymptote? 2. So our y asymptote has to go through 2, which is here. All right? So what does that tell us? Here comes the jets about to bomb, but they cannot get close, so they have to go up right there, and they cannot go past that, right? And the other one should be about right here. That's what you should end up with, right? That's why we need our asymptotes. Anyways, check this out. The rest of it is a piece of cake. All you have to do is build an input-output table. I want you to use values negative 1, 0, 1, 2, 3, 4, and 5. You're saying, why so many, Mr. Q? So you can have as many points to create that curve. Now here, all you have to do is substitute values in here. Check this out. Y equals 1 over parentheses minus 3 plus 2. What is my first value? Negative 1. Then you start having fun with fractions. Y negative 4 plus 2. You add these two, and so on and so forth. Are we there? So then this should be y equals 1 and 3/4. So this is 1 and 3/4. You plot your point, 1 and 3/4. Negative 1 and 3, and 1 and 3/4 is about right. Hey, I guessed it. Look at that. Bam. Everybody see that? So, and all you have to do is plot your points, graph your lines, and we're done. So, for homework. Homework is found on page what? 639, 1 through 23. Odd. Have fun, guys. Enjoy your homework. I'll see you guys tomorrow. They're tutoring today. See you guys here. Bring your snacks.